Good day, grade 12 learners. Welcome to our mathematical literacy lesson. I am Skulile Ngobe, and this lesson is proudly brought to you by the Northern Cape Department of Education in collaboration with Pagama Research and Development. This is our first lesson, grade 12s, when we are doing plans. We're doing plans under the topic maps, plans, and other representations of the physical world. Right, what are we going to learn under plans? Any idea? What things that we have learned before that we're going to use in this lesson? You have to remember what? The scale, your bar scale, your number scale, isn't it? You have to remember how to do basic calculations, just basic calculations. Remember, right, at the end of this lesson, grade 12, so we're going to look at what? We're going to use rough and scaled elevation plans. That is the front, back, and side, showing a side view perspective in context of complex structures. In context of complex structures like houses, RTP houses, and all those things, okay? Right, we're doing this in order to understand symbols and notation used on plans. Symbol and notations used on plans, and then also we are going to describe what is being represented on the plans. And then we're going to analyze the layout of the structure shown on the plan and suggest alternative layout options. We're going to look at that. And we're going to determine the actual length of objects shown on the plans using measurement and a given scale. It could be a number scale or a bar scale, right? And then we're going to understand terms like the north elevation. What is the north elevation? And then what is the south elevation, the east elevation, and the west elevation, and the relevance of compass directions in the construction of buildings. Why should my bedroom be on the northern side of the building? What's the reason behind that? We have to understand that. And then we're going to connect the features shown on the elevation plans with features and perspectives shown on the floor plan. Like I give you the elevation plan and I give you the floor plan, and then you choose which side or elevation corresponds to the side of the floor plan. That's what we're going to do. Right. Now, before we move any further, grade 12, I want us to do a baseline activity, just to revise the number scale and the bar scale. Right. I want you to start by doing question 1 and question 2. Question 1 and question 2. Right. Let's do that in 5 minutes. Right, welcome back, grade 12. Right, question 1. We're marking our work now. You are given a map with a number scale 1:60. Why don't we have units there? What are the units for this number scale? Why am I saying 1:60? So what are the units? Remember, grade 12, the number scale does not have units. We don't put units when it comes to number scale. It can be any unit, but now it should be 1 unit is to 60 units. The units must be the same. If I'm using meters, it means 1 meter is to 60 meters. If I'm using centimeters, 1 centimeter is to 60 centimeters. If I'm using millimeters, 1 millimeter is to 60 millimeters. So we can have any units here, and those units must be the same. So that's why we don't put the units when writing the number scale. Okay. This question is very, very common. They'll give you a number scale and say 1:250. They say, what is the meaning of this? I've seen that question a lot. What is the meaning of 1:250? It means 1 unit on the map or on the plan is equivalent to 250 units on the actual what? On the ground. Let me use on the ground. Or when you're comparing to the real length. You see that? 1 unit to 250 units, like that. You have to remember that. Right. So you are given a map with a number scale of 1:60. You measure a length on the map Now this is the length on the map of 10 centimeters. On the map is 10 centimeters. What is the distance in real life? What is the distance in real life? Remember the number scale, the structure of the number scale. It is plan. We're talking about plans today, so I'll be using plan, or it can be map is 2. Plan is 2, the actual. The length on the plan is 2, the actual length. That's what it means. Map to the plan, to actual. Plan to actual. Okay, what did I say? I said map to actual, plan to actual. All right. So now this is 1:60. 1 unit on the plan means 60 units on the ground. Okay. All right. So now we want 10 centimeters on the plan. What is it on the ground? We don't know. You can put a question mark there. We don't know. 1 centimeter is to 60 centimeters. But now, what about 10 centimeters? It will be how many centimeters on the ground? Or what will be the real length? What do we do? We have 1 here. We're saying 1 is 60. So what about 10? Just like, let's think about money. Let's say you're buying something. You're buying, let's say, sweets. 1 sweet is 2 rand. So what about 10 sweets? How much will they cost you? You just say 2 times 10, isn't it? It's the same thing. Here we're saying 1 is to 60. So what about 10? 10 is going to be 10 times 60. Do you see that? So it's going to be 10 times 60 here. 10 times 60, sorry for that. 10 times 60, which is what? 10 centimeters, 10 times 60, we get 600 centimeters. Okay, but we're talking about what? On the given map, what would be the appropriate unit here to use for this dimension? It should be meters, isn't it? So we can say this is 600 divided by 100. How do we convert centimeters to meters? Remember this, grade 12s. Right, from a bigger unit to a smaller unit, you what? You multiply. Most people think that from a bigger unit to a smaller unit, you have to divide. No, no, no. We have to multiply because there are many smaller units in a bigger unit. There are many centimeters in a meter. There are many meters in a kilometer. So now we have to multiply. From a bigger unit to a smaller unit, we multiply. From a smaller unit to a bigger unit, we divide. So now we're converting centimeters to meters. This is this part, centimeters to meters. We are dividing. Dividing by what? By 100. So the answer here should be 6 meters. So these 10 centimeters on the plan represent 6 meters on the ground. When I'm saying on the ground, I'm talking about the real dimensions. Okay, or the actual length, or the actual dimension. Right, so that's what we do then. Okay, but there's another way. This one will never go wrong. You don't even need to think. You don't even need to think. You write now, this is the plan or the map is to actual. Right, 10 centimeters, what is it? Is it the map, the length on the map, or actual is on the map? Write it underneath the map. Okay, right, we don't like X sometimes. Let me put another value which is not X. Let me just put, this is what is the distance in real life. Then let me use D for distance. Right, you do this. And then what do you do? Just cross multiply. You'll never go wrong. You say 10 times 60 is equal to 1 times D. Or 1 times D is equal to 10 times 60. Just do that. So 1 times D, what is 1 times D? Is D, which is our distance. 10 times 60 is 600, which we got here, 600 centimeters. Then you can convert your 600 centimeters to meters by dividing by 100. Okay, right. And then question 2. The distance on the map from Durban to Pietermaritzburg is 2.5 centimeters on the map. Use the number scale 1:3,120,000 to calculate the actual distance in kilometers. Like we said, this is the number scale. There are no units there. It can be centimeters to centimeters, can be meters to meters, can be kilometers to kilometers. But the distance that we are given on the map is in centimeters. So let's get our distance in centimeters. Then how are we going to convert from centimeters to kilometers? We have to convert from centimeters to meters, and then from meters to kilometers. Or you can convert once. I'll show you how to do that. Right, our scale, map to actual, 3,120,000. Then on the map is 2,5. So what is it here, actual? What are you looking for? Actual distance again. Let's put D for distance. Right, 1 is equal to 3,120,000. So what about 2,5? So you have to say 3,120,000 times 2,5. Let's do that. 3,120,000 times 2,5. I brought my calculator here so that I don't need to struggle. 120,123 times 2,5. What do we get? We're getting 7,800,000. Please, you should be doing this. Just do it with your calculator, and then what number do you get? 7,800,000. What are the units? We're using centimeters here, so we're getting centimeters. Okay, but they said in kilometers. They said in kilometers. Okay, so how do we convert centimeters to kilometers? From a smaller unit to a bigger unit, we divide. So from a smaller unit to a bigger unit, we divide. Centimeters divide by 100, we get our meters. Then divide by 1,000 to get our kilometers. Okay, right. And then, or you can divide once by 100,000. This 100 and this 1,000 will give you 100,000. You can divide once by 100,000. Okay, so let's divide by 100 first. Dividing by 100 is easy. 2 zeros disappear. Dividing by 1,000 is easy. 3 zeros disappear. You can even use your calculator, and then these 2 will go because of the 100. These 3 will go because we're dividing by 1,000 there. We divided by 100, divided by 1,000. Then what do you remain with? 78 kilometers. Does it make sense? Durban to Pietermaritzburg? Makes sense. Our answer should be correct, because you'll never get an answer which is not real in mathematical literacy. So every time check if your answer makes sense or not. You can't be getting 0.78. You're saying, oh, now this is the distance. My distance from Durban to Pietermaritzburg is 0.78 kilometers. No, it doesn't make sense, isn't it? Every time, check your answer and see if it makes sense or not. Okay? Right, question 3. I said do question 1 and question 2. Now we're doing question 3. You are given the following power scale. You see the power scale, right? You measure the distance on the map to be 30 centimeters. This is distance on the map. What is the actual distance? My first question is, before we do this, what do you do? What's the first thing that you must do when you're given a power scale, or you're supposed to do your calculations using a power scale? What is your first thing that you must do? You can raise your hand and answer this question. Let's try. Well done. Well done. The first thing you have to do is to measure the power scale. You cannot use a power scale without measuring it. You cannot use a power scale without measuring it. We have to measure the power scale. So now, for uniformity, so that we're doing one thing, I will do the measurement, and then after the measurement, I will ask you to do your calculations. Okay? Right. This is what I got when I measured. Right, you can pause the video here and take the measurement, and after that you do your calculation. Let me just show you Again, take note, from here to here is 50 meters because the ruler is going to cover that. And then from here to there is 100. Then from here to here is one. Okay. Oh, we're counting in 50. 0 to 50, 50 to 100, 100 to 150. So the black part only is just 50 meters, but the whole bar scale is 150 meters. So it's your choice. Do you want to use the black part only or the whole bar scale? Okay. Please, you can even pause the video here and draw the bar scale, just a rough sketch one, so that you know what we are talking about. Because when I bring the ruler here, it is going to cover these measurements. Let's just draw our bar scale, a small one, a rough sketch one, so that we know our measurements. Right. After drawing your bar scale, now this is the ruler. Now, using your bar scale, what is the actual distance? If the distance on the map is 30 centimeters, this also must be written. Just write distance on the map 30 centimeters. Distance on the map 30 centimeters. So if the distance on the map is 30 centimeters, what is the actual distance here? Let me give you 3 minutes for this. Right, welcome back. Now let's check. From here to here, the ruler is 1,5 centimeters, or the whole bar scale. It is what? We can say is 4,5 centimeters. So someone can choose to use the whole bar scale, or someone may choose to use just this small part here. Let's start with the small part. So we're saying 1,5 centimeters represent 50 meters. Remember, this is not a number scale. We can convert it to a number scale. And then for us to convert it to a number scale, remember, the units must be the same. We have to convert these 50 meters to centimeters first. And then we divide both sides by 1,5. Remember that, okay? So this is from the bar scale. So the units are fine like this when they're different. Centimeters and meters. Right. Now, so what about 30 centimeters? What is it? We don't know. 1,5 centimeters is 50 meters. So what about 30 centimeters? Becomes a bit difficult, isn't it? Because we don't know what 1 centimeter will be. So how do we get 1 centimeter? We have to divide both sides by 1,5. So it becomes 1,5 centimeters divided by 1,5 is equal to, or is to, 50 meters divided by 1,5. Okay, then 1, so meaning 1 centimeter is to 50 over 1,5. Sometimes if I want to write very long decimal numbers, I just leave it as a fraction like that. It's easier to use it as a fraction rather than to write a very long number, because during calculation we cannot round off. Okay, so what about 30 centimeters? If 1 centimeter is this, what about 30 centimeters? Then you just have to multiply this by 30. Okay, you just say 50 divided by 1,5. You can do that with your calculator. You know, there's this fraction, there's this function in your calculator. You just put your 50 there, your 1,5 there, then move your cursor here so that you times, then times 30, and then you get your answer. Let's see. 50 divided by 1,5 times 30. What is it? 1,000. 1,000. This is 1,000. 1,000 what? 1,000 meters. Because this side is centimeters. This side is in meters. So we're getting our answer already in what? In meters. So during calculation here, don't worry about the units. Okay, don't worry about the units there. Okay, again, we can use cross multiplication here. Just ignore the units and do your calculations without them. Right, so 1,5 is equal to, or is to 50 Okay, 1,5 centimeters is to 50 meters. And then what about 30 centimeters is to, we don't know. Then we cross multiply. But this one, let's put a letter here. What is the actual distance? Again, D. Let's put D. So it's going to be 1,5 times D, which is 1,5 D, is equal to 50 times 30. What is 50 times 30? Is it 1,500? Yes. There are 2 zeros and 15, 1,500. Okay. And then we divide both sides by 1,5. We want to get D. So we divide both sides by 1,5. Simple equation that we have done in grade 8 and 9. So we divide both sides by 1,5. So 15,000, that is 1,000, isn't it? Not 15,000, 1,500. Make sure you are accurate. 1,500 divided by 1,5. You're getting 1,000. You see that we're getting the same answer. Okay, so I prefer cross multiplication, but I want you to understand. Cross multiplication is just a routine procedure. You can even do it without understanding. Just put your map on one side, actual on one side, or plan on one side, actual on one side. Then cross multiply and solve for the unknown. Done. You never go wrong. Okay? Right. Now, we want to understand the floor plans or plans. Could be plan of a building, a stadium, can be anything, right? So what is two-dimensional plans? Two-dimensional. When I'm saying something is two-dimensional, what does it mean? It is two dimensions. It is two dimensions. So the plan or design having length, width only, but possible representing three-dimensional objects. I'm drawing something on a piece of paper. I can only see two dimensions there, length and width. There's no height. Okay, right, unless if I draw the 3D one. But if it's just plain like that on a, it's what? It's just 2D. Okay, right, I'll give you examples later. Floor plan shows the design and dimensions of the inside of the building from the top view. Top view, let's say you are something, you are on an aeroplane, and then you're looking at the building from the top. You remove the roof, everything, and then you're seeing inside from the top. What will you see? That's the floor plan, the view from the top. Okay, right, like an X-ray thing. It's like putting a house on an X-ray, and then you can see inside from the top, right? And then scaled elevation plans show the design and dimensions of the outside of the building from a side view using a specific scale. We're going to talk about these elevations, like the north elevation, south elevation, east elevation, west elevation. Right. North elevation, the northern side of the building. Please, I want you to take note of this. Okay. The explanation I'm going to do here applies to all the elevations, like south, east, west. But let's say this is the building. This is the building. So where is the north elevation of the building? Let's say the campus is like this. Where is the north elevation of the building? This is the side where we have the north elevation. Okay, it is on the northern side of the building. But as a viewer, where will I be facing? This is me here facing this side. I'm looking at the north elevation. So I'm facing which direction? I'm facing the opposite direction. This is my eye here. This is my eye. I'm facing which direction? I'm facing south, southern direction. So as a viewer, I'm facing southern direction. I'm seeing the north elevation of the building. This is the east elevation of the building. And my view is like this. I'm facing what? I'm facing western side. My view. I'm viewing like the western side. But I'm seeing what? I'm seeing the east elevation of the building. So this one is easy. Just follow the compass. North, east, south, west. Okay? Where is the side? Is it the northern side? That's the north elevation. Where is the side? East, east elevation. It's on the south, south elevation. West, west elevation. Not where I'm facing as what? As a viewer. No. Okay? If you look at the building, where is the side? in which direction of the compass is the side on. Okay, please take note of that. Let's go to questions. Now, when it comes to questions, this is what we're going to be doing throughout this lesson. So we have a question, you can have like question 1. Remember, there's question 1, then part of that question, isn't it? So I cannot display all the questions in one slide. So I have to show you question by question. And every question that I'm showing you, you must try it before I explain. So I'll be giving you time for each and every question. Could be 1 minute, could be 2 minutes, right, like that. Okay? If I say 2 minutes, do this, just do it, and then we mark our work. So we're going to be doing a lot of work, okay? Right. The diagram alongside shows the floor plan of Jan's house with a veranda in South Africa. Write down the number of bedrooms on the floor plan. This is about you recognizing from a given diagram. So write down, even the instruction, write down, no calculation there. Let's have 1 minute for that. Welcome back. Write down the number of bedrooms on the floor plan. The good thing about this subject, we are taught to be accurate and to be precise. You have to be accurate. Take your time. Don't undermine such questions and think that, oh, this one is easy. Check. Right. How many bedrooms do you see? 1, 2, 3. I need to confirm. This is bathroom, kitchen, living room, dining room, veranda. We have 3 bedrooms. You get your 2 marks. Done. Just be accurate. Don't rush. Take your time. Read the question. Literacy. And then apply your mathematics. Mathematical literacy. So make sure that you read the question and understand. That's part of the subject. Don't rush to the mathematics part. Understand the language first. Then you can apply your mathematics after understanding what the question is about. Don't start with mathematics, then you want to understand the question. No. Understand the information that you're given in the instruction or the question, then you do your calculations. The diagram alongside shows the floor plan of Jan's house with a veranda in South Africa. Same information. Which room will be the first room you will enter from the veranda? If you don't check, you just say which room you will enter first. You may think this is the time. From the veranda. So this is the veranda. So which room will you enter first? It should be the living room. Okay, and get your marks. We need these marks. For us to be able to get distinctions, we need each and every mark. Right, in which general direction does the master bedroom window face? It's a very common question. What do you start with when you get such a question? You may not answer this question without checking the compass. You have to check the compass first. That's the first thing you have to check. Because not like every time the northern side is on top. No. Check this compass. Where is the northern side? It's like pointing this direction. Okay. So now, where is the master bedroom window? Where is it facing? I can come here and draw my compass similar to this one, but now I'll put all the directions. So it's like this. So this corner is like northern side. Right. We usually say go not anti-clockwise, clockwise. You know how the clock moves. Go clockwise. I'm not sure if clockwise. I may be doing this while it's there, you're seeing me doing the other way around. So I don't want to use these things. Sometimes the directions may confuse you. Just look at your clock or your watch. How does it go? How does it move? It goes clockwise, isn't it? Like from left to right, sort of. From left to right. Right? So we go this way. And then we say never, ever, that's never, ever smoke weed. It's an advice. Okay? Never, ever smoke weed. Remember that. So that will assist you a lot. So where's the north, where's the east, where's the south, where's the west? So now if you check this window, it's like this direction. Then what is the direction between north and east? That is northeast. So without checking the compass, you may not answer this question correctly. That's the first thing you do. Check the compass. When you're asked which direction, check your compass. And then you fill in, never ever smoke weed. All right. The diagram alongside, oh, this is the same information, I think. Let's not worry about that. Write the probability. We're bringing in all these questions, all these concepts in simplified form, that it is not one of the interior doors. Not interior doors. It means what? So they're the external doors. Okay. So how many doors do we have in total? That is our what? Possible outcomes. Right. We have 1, 2, 3, 4, 5, 6. And then which ones are not interior doors? So it's 1, 2. Okay. Right. So we have 2 doors which are not interior out of 6. So the probability of not interior is equal to 2 over 6. But what did they say? In simplified form. So it's 1 over 3. If you're not told to write it as a percentage or a decimal, leave your probability as a fraction. Okay? Right. So it's 1 over 3. Jan remarked that the kitchen gets a lot of sunlight. Critically comment on this remark. It's another crucial question, this one. I've seen it a lot in past papers. Jan remarked that the kitchen gets a lot of sunlight. Let's check this. Where are we on Earth? Where are we on Earth? Yes, it's fine. South Africa. Where is South Africa? This is the Earth. This is the equator. This is the equator. And then the sun is spending most of his time here around the equator then. Then remember, this is the northern side. North, you find Egypt, Libya there at the top. Right? Here is South Africa here. Here is South Africa here. You see that? And then the sun is on the northern side. Do you see that? The sun is this side, here, on the northern side. So if I want to enjoy the sunlight or the warmth of the sun, the windows of my house or the windows of my room that I want to be warm must be on the northern side of the house. Should be this side. The windows should be on the northern side of the house so that we can have more sunlight or more warmth from the sun getting in. Do check that. When you get home, do check. Check the rooms that are very cold, especially now it's winter. Check the rooms that are cold and check the rooms that are warm. You see that the ones on the northern side of the house, they are warmer than the ones on the what? On the southern side. In most of the times, the main bedrooms, that's where you find them on the northern side of the house, because that's where we want what? The warmth from the sun. So always check for that. So now, which side of this house is northern, on the northern side? Check the compass, it's like this. So this is the northern side. So this side is the one that is going to be warm. So to say that the kitchen will get a lot of sunlight while it's this side, no, it's wrong. It's wrong because the kitchen is like on the southern side. Okay, so the side that will be warm is this side. The living room, the bedroom, and the master bedroom 2 and the master bedroom. Okay, please take note of that. It's a very, very common question. You even saw it in our objectives, isn't it? All right. And then give one reason why the windows shown in the artist's drawing of one of the elevations do not represent the windows of the kitchen and dining room. Remember, I don't need to remind you every time. If I give you a question, once you see a question, just pause the video and answer. the question before I explain. Right, let's do this one. Right, welcome back. Now give one reason why the windows shown on the artist drawing. This is the artist drawing. Right. Do not represent the windows of the kitchen and dining room. These are the windows of the kitchen and dining room. This side, this is the window, this is the window there. But artist drawing, there's a pillar there. You see that? This is this pillar there. There's a veranda. This is the veranda. There's a window. This is the window there. There's a window there. This is the window there. And then the door. This is the door there. So this artist drawing is actually showing us which elevation is this? This should be like, this is northeast. So this should be the east elevation, this side. Not the kitchen and dining room one, no? No, it should be this side. So check for those. Remember, we talked about this, objectives. We want to link the elevations, what we see on the elevations and what is on the plan, on the floor plan. Okay, you should be able to link these two. Okay, right. Again, if you check this side where there's dining room, kitchen, this window was supposed to appear. And then this part also was supposed to appear. We can't see all those things here. Okay, so you should be able to link these two, the floor plan and the elevations. Okay, you will get questions which require you to do that. To me, rented a 1,045 square feet apartment whilst he was studying. Alongside the layout plan of the apartment, the dimensions are given in feet and inches. What is the general direction of the living room from the kitchen? Must get this one right. Let's try. Right, this is the compass. North, this side. Never, ever smoke weed. Right. So, what is the general direction of the living room from the kitchen? So, from the kitchen. So, that's where we put the compass. From. So, our compass should be here. From the kitchen to the living room. So, this is west. You see that? So, the living room is on the western side of the kitchen. So, it's west. If you did not check the compass, we are going to say this is northwest. Do you see that? But check the compass first before you answer these questions. Verify showing all calculations whether the balcony with dimensions of 26 feet, 10 inches by 4 feet is greater or less than 109 square feet. Now we have a problem here. Oh, by the way, we have to try this before I explain. Let's try it. Right. We have 26 feet and 10 inches. So how do we deal with that? Okay, there's this information here. Let me make it clearer. This is the information. 1 foot is 12 inches, then 1 inch is 25.4 millimeters. So now what do? We need to find the area of this balcony in square feet, and then after that compare and see if it's 109 or less than or greater than that. So we have to convert 10 inches to feet. We're told that 1 foot is 12 inches. So 1 foot is equal to 12 inches. So what about 10 inches? How many feet? We have to find what 10 inches will give us. 10 inches. See, I'm writing inches on their own side and then feet on their own side. And then let's say F for feet. Right. So what do? We can divide both sides by 12 so that we can get for 1 inch. So 1 over 12 feet is equal to 1 inch. How did I do that? I divided by 12 on both sides so that I can get 1 inch there. Now I know that 1 inch is 1 over 12. So what about 10 inches? I just do what? I just say 10 times 1 over 12. And then what do I get? This is like 10 divided by 12. 10 divided by 12, which is 0.83333333. It goes on like that. So this is like 0.833333 goes on like that. And then 26 feet plus 0.833333 will be 26.8. 26.8. 3. Let me check the calculator. How many threes do you have? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. Like this. Okay? This is the length of the balcony times 4. What do we get? If you say times 4, this is like plus 26 equals, and then times 4, what do we get? 107.333. 107.3333 goes on like that. Square feet. And then you can say now, no, this one is less, actually less than 0, not 100. This is 107.333. So this is less than 109 square feet. Right. Like cross multiplication, you could have used it here. You say 1 foot, 12 inches. What about 10 inches? Then you put your F there for your feet. Then cross multiply. 12 times F is 12F. Then 10 times 1 is just 10. Remember, I said you ignore units when you're cross multiplying. Then for your F, divide by 12 on both sides. 10 divided by 12. Then this was going to give you your 0.833333. Then you add that to 26. Becomes 26.833333 feet. That's your length times your width, because the length of a rectangle is the area of a rectangle is length times width. Then you get your area, which is square feet. Like that. Then you can compare now. Okay. All right. And then we have another one. The southwest facing wall. Southwest. Excluding the balcony is 25 feet. It's given there. Measure this distance on the layout plan to determine the scale in the form 1 centimeter to dash feet. Right. So we measure this. If I say measure there, we're going to get different things. Let me do the measurement using my ruler, and then we are going to use that. Okay. Right. Let's try to answer this question using this measurement. Right, welcome back. So we can see here that 7 centimeters is to 25 feet. But now they said we must write it in the form 1 centimeter to dash feet. Right, they said in the form. So what do we do? Divide both sides by 7. Divide by 7. Divide by 7. So 1 centimeter coming from 7 divided by 7 is to 25 divided by 7. 25 divided by 7. 25 divided by 7 is 3,57142. So it's 3,57142. Goes on like that. So this should be 1 centimeter is to 3,57. Because they didn't tell us to round off to the nearest whole number. But if they said that, it was going to be 1:4. Okay, most of the time the scales will find them that we use whole numbers. Okay, but you are not told anything unless if I'm missing something. Okay, it's fine. So we leave it like that. Okay, if they said whole number, it was going to be 1 centimeter to 4 feet. Right, and then we're doing this question. To me, rented is the same information. To me, rented 1,045 square feet apartment. To me, monthly rent for your apartment is 2,188.71 cents. This is Canadian dollar. Calculate the rental per square feet. Per square feet. Per means what? Divided by. So this will be the amount divided by square feet. If I say find the speed in kilometers per hour, it means kilometers divided by hours. If I say meters per second, it means divide meters by seconds. If I say rands per kilogram, means divide your rands by kilograms. So you want to calculate the rental rate per square feet. So you have to say the amount divided by square feet. Just that. Remember that. Okay. Right. So it's going to be 2,188.71 divided by the square feet, 1,045. All right. And then what do we get? 2,188.71 divided by 1,045. 2 Canadian dollars, 0.94. So it's going to be 0.9. Let me write it before rounding off. 0.9445933, which is 2.09 Canadian dollars per square feet. That's right. $2 Canadian dollars and 9 cents per square feet. That's the answer. Just remember that per square feet means divide your amount, your rental amount by what? Per square feet. Percent. Okay. Percent, remember percent is coming from what? Cent is to do with 100. That's how you divide by 100. Per megabyte, you're dividing by megabyte. Okay, right. I'm trying to think of other examples. Right, the next question. Alongside is the layout of the laboratory where Tony works. Which item is located at the far left hand corner of the laboratory as a person enters the laboratory? There are two things here. It should be far and left. Far left hand corner, and it should be at the corner. So which is what? The fume hood. This one. That is far left hand corner. Okay. Right. Let's not forget to pause the video. When I give you the question, pause the video and try the question before I explain. How many microscopes are in the laboratory? How do we see microscopes here? So once you see such a diagram, it means that these items are represented by something, right? So these are the microscopes. So always check your key. And then, so how many of these do we have? 1, 2, 3, 4, 5. So we have 5 microscopes. So always check your key. That's another thing that you must remember when you're dealing with maps and plans. Calculate the width of the laboratory if the total area is 18.9 square meters. We're given area here. Then the formula for area does not change. Where you're going to be given a question and you have to manipulate a given formula, right? It's not like always you are given things you have to substitute and calculate. No. Sometimes you have to manipulate the given formula. So area is equal to length times breadth. So we have the area 18.9 square meters is equal to length, which is what? 4.5 meters times the width, which is the breadth. Width and breadth means the same thing. Then now, What do we do to get width? Remember simple equations when we do inverse operations. So what we do here is 4,5 times width. So we have to do the inverse of timesing, which is what? Dividing. So we divide by 4,5, divide by 4,5. Then we remain with width. And then what is 18,9 divided by 4,5? 18,9 divided by 4,5. We get what? We get 4,2. Right? So this is 4,2 meters. The width is 4,2 meters. If you say 4,2 times 4,5, you'll get 18,9 square meters. Okay? All right. The scale used on the layout plan is 1:58. Calculate the actual length of the table on the layout plan if its scaled length is 2,26 centimeters. Again, we have 1, which is the distance on the map. 1 on the map is 58 on the ground. This is the distance on the plan. So we put it on the plan side. 2,26 is 2. We want to calculate the length. Let's use L for length. And then 1:58. What about 2,26? It's easy, isn't it? 2,26 is going to be 2,26 times 58. Then this one is going to be 2,26 times 58, which is what? 2,26 times 58, which is equal to 131,08. 131,08 what? Centimeters, because these are centimeters, so centimeters. They didn't tell us which units to use, so let's leave it as centimeters. Fine, makes sense. You can leave it as centimeters. But if you want to convert it to meters, you can divide by 100. You get 1,31 meters. Right, this one, like I said, you can just cross multiply. 1:58, then 2,26 is to the length. Make sure that the distances on the map are on one side and then the actual on one side. Then cross multiply. Cross multiply. Right, 1 times length, that will be length. 1 times length is 1 length. And then we have 2,26 times 58, which is what we did here. You see that? So if you just cross multiply, you'll never go wrong. Okay. A construction company decided to donate a new swing, slide, and merry-go-round for the park next to the RDP houses. The sketch below shows the layout of the park. Use the layout alongside to answer the questions that follow. Right, let's try to answer this question. Right, which entrance is north of parking area 1? Parking area 1 is here. And then the campus is here. So the entrance in the north, that's entrance 2. That's entrance 2. Please write that as your answer. Right? And then what is the general direction of merry-go-round from the open field? From, that's where your compass must be. From the open field, take your compass there. North, east, never ever smoke weed. Then where is the merry-go-round? This side. So this should be south east. Southeast. Okay, that's the direction of merry-go-round from the open field. So from, that's where your compass must be. And then a teacher drew a scale drawing of the park using a scale 1:250. If the actual length of the parking area 2 is 15 meters, parking area 2, where is it? Here is 15 meters. Determine the length in centimeters of parking area 2 on the teacher's drawing. Can you try to do this? Right, let's do this together. So 1:250. Plan to actual. Now, if the actual length, be careful here, the actual length of the parking area is 15 meters. So we write the 15 on the actual side. Okay? Right, what is the length on the plan. You see that? So now you have to be careful there. Right, now, how do we get 1 from this? 250. How do we make it 1? We have to divide by 250 on both sides. So it becomes 1 over 250 is 1. After dividing by 250 there, dividing by 250 there. So again, what about 15 meters? We don't know. If 1 meter actually, or on the ground, represents or is represented by 1 over 250 on the plan, what about 15? You have to say 15 times 1 over 250, isn't it? 1 is this, 1 is this. So what about 15? We have to say 15 times that. It's going to be 1 over 250 times 15, which is what? 15 divided by 250 is same as 15 divided by 250. You get 0.06. But what are the units? Meters. And then on the plan here that I'm drawing, what is the realistic unit that I must use? It should be centimeters. How do we convert meters to centimeters? We multiply by 100 to become 6 meters. This can fit on the what? On a piece of paper that I'm drawing my diagram on. Centimeters. 6 centimeters. Okay? Right. Makes sense? If I was finding the distance on the map, then I find that it's 6 meters. How do I fit 6 meters on a paper? So this answer makes sense, like I said when we studied our lesson. Right. The following is a scale diagram of AA High School administration block. Which rooms lie southwest of the administration office? Southwest. Right. So from where? From the admin office, north. So you see north. Never ever smoke weed. So southwest is this direction. So which rooms are we talking about here? The stationery room, kitchen, or waiting area is not a room. So the stationery room, kitchen there. Any of those two. Okay. What about staff room? Staff room stretches up to there. So the most appropriate ones would be staff room and the kitchen there. Okay. The width of the printing room on the scale diagram is 1,33 centimeters. Use the given scale to calculate the actual width of the printing room in centimeters. Let's try to do this. Right, welcome back. The scale is 1:300. Plan to actual. Now, this is the distance on the plan. So we write it here, 1,33 is to the width. Okay, so let's put W there for width. Right, and then what do we do? 1 is 300. So what about 1,33? It's going to be 300 times 1,33. 300 times 1,33, which is 399. Oh, we have to show the method. 1,33 times 300. Right? So it says the width of the printing room on the scale diagram is 1,33 centimeters. Use the given scale to calculate the actual width of the printing room in centimeters. Oh, so we're not converting anything here. So the answer is 399 centimeters. So the width of the printing room is 399 centimeters or 3,99 meters, but they say centimeters. So this is the answer. Makes sense. But 4 meters makes sense. Okay. Or you could have done cross multiplication here, like you say 300 times 1,33, which is this. Then 1 times W, which is what? W. So W is equal to 300 times 1,33. So if you use cross multiplication, you don't even need to think, just cross multiply. Make sure the dimensions on the map one side, the actual dimensions one side. Then cross multiply. You'll find the unknown very easy. Jane and Tom are newlyweds. They plan to build a house using floor plan and elevations shown below. It's now alongside. How many bedrooms are shown on the floor plan? Just counting and being accurate then. 1, 2, 3. Do you have any other bedroom? No, we don't have. So it's 3 bedrooms there. 3 bedrooms. Okay. And then the elevations are numbered 1, 2, 4. Match the west, north, south, and north elevations. Right, west. The compass is here. So this is north, and then east, south, west. So the west elevation is this side. This is the west side. Right. Now, and then as a viewer, where am I facing? I'm facing the eastern side. You see that? I'm facing that way. This is the west side, and I'm facing to the east. Now, if I'm facing to the east, this part of the building should be on my right. This is the west elevation of the building. I am facing the eastern direction. Then this part of the building must be on my right. That means this must be on my right. So this is the east elevation. No, west elevation. I'm facing east direction. This is the west elevation. Then east elevation. East is this side. This is the east elevation of the building. Then as a viewer, I'm facing this direction. I'm facing to the west. I'm seeing the east elevation. Then as I face the western side, seeing the east elevation, this must be on my right. Do we agree? It must be on my right. So meaning that this is the east elevation of the building. I'm seeing the east elevation when I'm facing west. Please take note of that. I explained this when we started the lesson. Then the north elevation. Let's start with the south. The south elevation of the building is this side. This is south. This is south. So I must be able to see this part of the building again. So I'm facing north. As the viewer, my eyes are towards north. I'm seeing what? I'm seeing the south elevation. So this part of the building must be there. So this should be the south elevation of the building. It's on the southern side of the building. And then this is the northern side of the building. There's no door here, just windows. You see, windows only. You see, there are windows only here. But as a viewer, I'm facing this direction. I'm facing the south direction. I'm seeing what? The north elevation. So this is the north elevation. Okay. This is the north elevation of the building. Okay. Please take note of that. All right. And then is this plan for a single or double story house? Double story. We have the ground floor plan, the first floor plan. You can also see here, we have the windows for the ground floor, we have windows for the first floor. Okay, right. You should be able to read all these things from the plans. Okay, right. So we're going to do more questions when it comes to this, especially the use of the bar scale and the number scale, identifying your directions correctly, identifying your elevations correctly. And then these other things, you should be able to use your keys correctly. Check your keys. Compass, don't forget. Always check and make sure that you have checked the compass before you answer any question about what? About direction. Okay, right. And then Mrs. and Mrs. Swart retired recently. They intend to move to the complex for senior citizens, which is still in a developmental stage. They were provided with several floor plans from which they could choose the type of house which they may fit, the type of house that may fit their lifestyle. They were allowed to suggest a reorganization of the inside layout, but the exterior walls must remain as shown on the plan. Use the plans and information provided below to answer the questions that follow. You can also pause the video here and read the information and try to understand. So now, explain which rooms in the plan will be warmer. We've done this question. Than the others during the winter month. If no heating equipment is switched on, substantiate your answer, means support your answer. Right, this is the north and this is the compass. We said that when we're building our houses, if you want your room to be warm, it must be on the north elevation of the house. So where is the north elevation of the house here? This is the north elevation of the house. This is north, according to this compass. So the house that are going to be warmer here is the master bedroom and the dining. Okay, because in South Africa, most of the times our sun is on the northern side. Okay, we're on the southern side of what? Of Earth. In South Africa, this is where the sun is. So the north elevation side will be receiving more sunlight and more sun warmth. Use the compass direction to appropriately replace C. What is elevation? C. Where is C? This one. Which elevation is this? Where we have a window and a door, nothing else. Here we have a window, a door, and a window is out. We don't have a window there, it's out. Window, 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 door is out. Let's check this side. Door, window. Yes, that's the one. We have a door and a window here. So this is the elevation we're looking at. Where is it? This north, east, south. So it's east elevation. It's this side, east elevation. Okay, right. Check that. And then name 2 rooms without windows on this plan. This is also guiding us. Discuss any challenge that an occupant of the building may experience due to the lack of windows. Check this. This is the bathroom. We have toilets there. Bathroom, toilets there, no windows. So what is going to happen there? No ventilation. Maybe smelling. Maybe also moisture, humidity, moisture. There's a lot of moisture from bathroom. There's steam and everything. So how will this steam move out of this room? It's going to be humidity and moist, and then it's going to develop a mold. Molds. Yeah, like rotting. The walls of the bathroom may start rotting. So there must be enough ventilation for such. Every room must have ventilation or windows. Right? Discuss any challenge that any occupant of the building may experience due to lack of windows. I think we've covered that. So it's like an open-ended question, right? Explain one layout change that you will make to this house if you're buying the house. Substantiate your answer. I think the previous answer informs us what you should do here. You must have windows, but like this one again may have windows, but it's leading us to, the windows may be leading to other rooms. So it may be moved to the sides of the building and then have windows. Again, it's sort of like an open-ended question where your opinion may be considered, but it must be appropriate. You don't just say anything. You should have an opinion that you can what? You can substantiate, support your answer. Right. You must have windows so that there is what? Ventilation. That air can come in, and also to avoid moisture. You can move this to the side and open the windows so that the windows do not lead to the other rooms. Okay. Any appropriate answer will be there. It will be fine for that question. Right. This is your homework, grade 12s. You can take your time. If you can take a picture, if you can copy it, it's fine. It's fine. So this is your homework. You may do this homework and submit your work. Okay, we've come to the end of our lesson, grade 12s. Thank you very much for joining us for this lesson. We're going to meet for our next lesson. Thank you very much. Goodbye.